let's go over the basics of all of them. Just remember all the rules that we go over and things that we go over. I'm really just going to follow the same exact thing as you did in elementary school. So sidebar is this, is that what we just got finished doing was basically this. Let's do like 9 over 27. And I had you guys factor top and bottom, right? And you found out that, well, the top equaled 3 times 3, the bottom equaled 3 times 3 times 3, and anything's the same cancels out, and of course if there's nothing left on top. Right, that's basically what we just did, just the algebraic version. So we'll be doing the same thing right now with multiplying, dividing. So you remember a while ago you did this, you might have like 3/7 times 14 over, what's a good number, 30, something like that. Same idea, we'll factor top and bottom, so like 3 you can't factor, 7 you can't factor, but 14 factors to 2 times 7, 30 factors to 3 times 5 times 2. Right? And then anything that's the same top and bottom cancels out. But the new thing is that you're also allowed to cross cancel, because really this is like one big fraction. So we can cross cancel as well. And as you see here, everything cancels out except for the 5 down below. Once again, answer's 1/5. Be very careful not to say, oh, I have a 5 left over. The answer's 5. Okay, the position top and bottom makes a difference. And lastly, the thing that you guys did a long time ago was dividing. So what happens when you divide? Yeah, so 3/5 divided by 1/5 is the same as 3/5 times 3. That's what I said. Control Z. There we go. 5 over 1. And then, of course, if you can, cross-cancel anything that's the same. So recall that if there's a 1 on the bottom of fraction, we don't need to write it as a fraction, just write it as an integer. So we're just going to apply all that, just including variables. The first 3 are already factored. So just imagine I already wrote it out as 14 as 2 times 7 and 30 as 3 times 5 times 2. It's already been factored for you, so you have to pay attention once again to, well, it's division. So, and this is the part that might make some of you suffer. The rest, most of you are going to not mind this at all. But there's a lot of recopying, and resist the temptation to not do it. Well, I'm just going to flip it in my mind and then cancel things and try to come up with some way of saving 20 seconds of writing, but then of course that usually turns into a bunch of mistakes. So just go ahead and rewrite that whole thing. Flip the second one. Even if you think it seems like a waste and you don't need it, do it anyway. It's just good advice. And then start doing the canceling. If you prefer, you could put parentheses on binomials. And so what cancels? 4s. X minus 3, cross cancel. Okay. You might notice that a 4 and the 2 goes into 4 2 times. Exciting, I know. I had the same reaction when I first did this. and then the 2's cancel as well. So your final answer is what? X plus 3 on top, x minus 6 on the bottom. Now, is this finished?
No.
Yes, it is. So what we just did is the easy part. Okay, so we can factor, once it's already factored, yeah, we can see if anything's the same top and bottom, no problem, right? Two things that will come in your way. Most of these are not factored. You'll have to do GCFs, you'll have to do the box, you'll have to do the X as needed. Okay, but the second thing and the more complicated thing for you guys that you have to be aware of is this. Okay, is when not to cancel. So you have to have some sort of guidelines here. So I want to replace this variable x with just a number. What if I said this was 1 plus 4, I guess it'd be plus 3. Actually, I use plus 3. So I'm going to take out x, I'm going to put in plus 3, and 1 minus 6. Right. So what does this equal? 4 or negative 5. Now, what happens if I just cancel out the 1's? Do I get the same answer? 3 over negative 6, which equals negative 1/2. So as you can see, if you do it the long way and you get an answer, and you take a shortcut and you get a different answer, that means it's not a shortcut. It means it's wrong. So that's why we cannot just cancel out the x's. Okay. Go back. What if, instead of canceling out the 1's, what if you're thinking, well, let me reduce 3 over 6. Do you get the same answer if you reduce 3 over 6? And change this to 1 over 2. 1 plus 1 is 2. 1 minus 2 is negative 1. No, you do not get the same answer. So you have to keep this in mind about these problems and what you can cancel and what you cannot. That's the most clear way of putting it and stating it. I know I say this, but if right now you're not paying attention, you're doing something else, you might just raise your hand and ask me the same question all over again. It's like it every single time. So try not to be that person that, after I've gone over it, you say, well, how come this and how come that? Okay, it's as simple as taking out the variables, putting in the same number, and saying, well, if I had a number there, would it work? If it doesn't work with numbers, that means you can't do it with variables. Okay, period. So we have to say we're okay with that, and we're going to resist the whole idea, but the same thing's on the top and bottom. Now, why are you thinking this in the first place? It's good to think about what you're thinking. It's called metacognition. Think about your thinking. Why would you have a tendency to want to cancel something right now? Okay? You're thinking about this. 3x over, let's say, negative 6x. This is all multiplication, and yes, that cancels out easily, and this cancels out. Okay? When it's all multiplication. That's why you're thinking about doing that and why you want to have this urge to cancel stuff out. So being aware of that, seeing how that was all multiplication, right? Okay, now you know the differences. This has adding, subtracting, this does not. You can cancel when you have all multiplication, but you cannot cancel when you have adding and subtracting, separating them. Notice how up here, this is multiplication. That's why we can cancel out x plus 4 and x plus 4, because they're being multiplied. But we cannot cancel out plus 3 and minus 6, not being multiplied. So use that as your rule for, am I allowed to cancel or not? Okay. Only if it's being multiplied, only if it's a factor. Alright, good. Let's look at another real fast. I'm going to do just a couple more. 4 I wanted to talk about. It has a special quality to it. So once again, first thing I notice I'm going to look at, if it's division, I'm going to start rewriting the problem into multiplication. Don't even think about, well, what's going to cancel, what's going to change. Do that next. Okay. Times 3x minus 4 on top and 2x minus 7 on the bottom. And if you prefer, you can put these in parentheses. That helps. Okay, so what cancels out? 3x minus 4s, 2x minus 7s, and 9 divided by 9 equals 0 or 1? Alright. Common wrong answer is 0. Well, everything's gone. There's nothing left. The same thing. What's the same as nothing? 0. So remember, 9 divided by 9. How many times is 9 going to 9? That's 1. So it's the same rules here. 2x minus 7 divided by 2x minus 7. How many times does 2x minus 7 go into itself? 1. So make sure you don't say 0 here. So from this point on, after 4, you're going to have to factor. So it might be GCF work, so like number 5. What's the GCF here? 6n. Right, so if we don't do GCFs correct, we might run into issues. Of course, this is multiplication, division, so rewrite as multiplication. What's the GCF? Is there a GCF here on the bottom? Okay, it's a little more difficult. What's the biggest number that goes into 21 and 63? 21. So you're going to come across this where, well, I know 7 goes into 21 and 63, so it's 7, because it's not the biggest number you can think of. It's the actual biggest number. So we have to be very careful. I'll show you in a second how we can avoid that. So we have, if you factor, let's say you took a 7 out, you would have 3n plus 9 left over. Always look at what you just factored and say, well, does something else come out of this? You say, oh yeah, 3 comes out of both of those. Okay, so now you have a 3 coming out of both of those. And there's your GCF. It was a 21. So whether you remember, 21 goes into both these or not, as long as you do this check after you do a GCF to see if anything else comes out, you're okay. And then once again, okay, 21, 6, anything? 21 is what? 3 times 7. 6 is 2 times 3. Right? So yeah, 3's cancel out. So we're left with 7 over 2. Is that right? 2n, yeah. 2n. Don't forget the n. Good. GCFs. So realize if from the very beginning you saw this right here and you said GCF is 6, nothing will actually end up happening. So you don't take out the n as well, you'd have an n squared plus 3n, which would not cancel here. If you only took out a 7 from here, not 21, same thing, you wouldn't have anything canceling. So it really forces you to make sure you do each step correct, because you can't move on and nothing will cancel otherwise. So if you get stuck, ask yourself that. Did you just pick something and take it out, but not take out everything? Of course, when we get to trinomials on number 6, okay, you can use the x. What two numbers multiply to 4, add to 4, right? And factor that way. And and then see if anything cancels. Looks like it will. Let's look at the back. Yeah, let's do something like those are actually bigger numbers than I'd like, but it's okay, it's good practice. When you come across these nice large problems, I want you to use the context fractions to help you out. So you might be looking at something in number 10 and saying, well, I have to figure out what multiplies to 21 times negative 8. Right? 21 times negative 8, and what adds a negative 22. Okay? That's kind of difficult. So if this was just a problem by itself on this test, it would be, it'd take some time to figure that out. But we know that all these problems are kind of set up for things to cancel. So if you see a 21 on the top and you see one term that's 3n and the other term that's 7n, that's kind of a hint that this probably factors to these two below. Okay. So you can try it out and say, oh, let me just make sure. Does 3n minus 4 times 7n plus 2, go in and check to see if that actually equals this. And when you do that, okay, you get 21n squared, we get negative 28n, we get positive 6n, and then we'll get negative 8. And you can see, alright, negative 28 and positive 6, that gives me negative 22. So if I was going to go through and factor this, I would have gotten negative 28 and positive 6, and it would have worked out. So don't just work on these from the front end and just try to factor it. Try to look around and see, maybe make some educated guesses.
Where did you get positive 2? Or you just did that's where?
Positive 2 where?
On the box.
Here, where did I get this from?
Yeah.
I just grabbed these.
Oh, no.
Yeah. Yep. It's almost the end of the day. Alright, so same thing over here. Once you factor the GCF out here, whatever's remaining, try to use that as help to figure out what this factors to. All else fails, you might do some synthetic division to help you out if you want to try that, see if it divides in, or long division. Okay. Alright, so I'll let you guys work on that. We want to have this done, begin the period tomorrow, and we'll do some adding, subtracting tomorrow.